have you ever stopped and wondered how your laptop, your phone, your TV, everything can all be streaming and browsing and connecting at the same time, all using just that one internet connection you have? Well, the answer is this really clever trick called Network Address Translation, or NAT. It's kind of like the invisible hero that makes our entire digital life possible. And today, we're going to pull back the curtain and uncover its secret.
So let's start with the central puzzle, right? You've got one internet line coming into your house, but somehow you might have a dozen different gadgets all using it at once. How on earth does that actually work?
I mean, seriously, think about it for a second. If you're streaming a movie on your TV, maybe someone else is on a video call in the other room, and you're scrolling on your phone. How does the internet keep all that data from getting mixed up? It really feels like it should just be total chaos. But nope, it all works perfectly because your router is secretly playing traffic cop. Yeah, that humble little box with the blinking lights, it's doing way more than you think. It's a super clever gatekeeper, a master translator that's working nonstop behind the scenes to manage all that traffic.
And at its heart, the whole idea is surprisingly simple. Think of NAT like a parent managing the family's mail. All the letters going out use the one main house address, right? But when a reply comes back, the parent just knows exactly which kid it's for. That simple act of just remembering, that's the real magic of NAT.
In fact, you know what? There's an even better analogy to make this crystal clear. Let's forget the house for a minute and picture a big, busy hotel instead. This will lock in exactly how NAT gets the job done.
So here's how you can think about it. Each one of your devices, your laptop, your phone, whatever, is like a guest staying in a different hotel room. Now, the hotel itself only has one public street address. That's your internet connection. So when a package of data arrives at that main address, the front desk, which is your router, it checks the specific room number. In networking, we call this a port number. And then, bam, it delivers the package to exactly the right guest. It's such a simple and brilliant system. Okay, so to really get this, you've got to think in terms of two completely separate worlds. You have the private, inside world of your home network, and then you have the public, outside world of the internet. NAT's whole job is to be the bridge between them, and it does that by managing two totally different kinds of addresses. And this lays it out perfectly. On the inside, in your home, your devices have what are called private IP addresses, something like 192.168.1.10. Think of these like first names inside a family. They only need to be unique inside your house. But on the outside, your router has one single public IP address given to you by your internet service provider. This is like your home's unique street address, the one that's visible to the entire world. So here's what that looks like in the real world. Inside your local network, your laptop might be .10, your phone could be .11, and your tablet is .12. None of these addresses can actually be used on the public internet. They are strictly for internal use, and your router is the one keeping track of them all.
All right, now for the main event. Let's actually see how the router performs this amazing sleight of hand. We're going to follow a single little packet of data on its journey from your laptop out to the internet and all the way back again.
So it all starts right here. You type a website into your browser, you hit enter, and your laptop sends out a request. The from address, the source address on this little data packet, is its private internal IP, 192.168.1.10. That request then zips across your Wi-Fi and makes its first stop, your router. And remember, the router is like the border crossing, right? It's the official gatekeeper between your private home network and the huge public internet. And here is the magic trick. The router takes your laptop's private from address and just swaps it out, replacing it with its own public IP address. So now, as far as the rest of the internet is concerned, the request came from the router itself.
But you're probably asking, how does it remember who to give the reply to? Well, this is the key. The router makes a quick note in a special little logbook called a NAT table. It basically jots down, hey, that request from the laptop at 192.168.1.10, I sent that out. I'm waiting for a reply for that specific one.
So a few milliseconds later, the website sends a response back. But it's not addressed to your laptop's private IP. I mean, the internet has no idea that address even exists. The response is sent back to the only address it ever saw, your router's public IP.
When that reply hits the router just checks its little logbook. It says, here's that answer I was waiting for. This one belongs to the laptop. It then performs the swap in reverse, replacing its own public address with your laptop's original private one, and forwards the data right to your screen. And get this, it does this millions of times a day without even breaking a sweat.
So you might be thinking, okay, that's a neat little technical trick, but why does it actually matter? Well, this one trick is honestly one of the foundational pillars of the modern internet. It solves some absolutely huge problems.
So what is the big deal? Well, first off, NAT pretty much saved the internet. No exaggeration, we were literally running out of unique public IP addresses, and NAT let millions of private devices all share a single public one. Second, it's the whole reason you can connect everything at once. And third, it adds a nice basic layer of security by hiding all your personal devices from the public internet, which makes them a whole lot harder for anyone to target.
It really is the invisible engine of all our connected homes. So the next time you have like 10 different devices all running on your Wi-Fi without a single problem, you'll know the secret. It's a little bit of translation magic happening right inside your router. Makes you wonder, what would our daily digital lives even look like if this simple trick had never been invented? It's really something to think about.
Okay, students, so we have a packet tracer here that we want to get into. We want to examine NAT on a wireless router. It's a simple packet tracer, but I know that you have completed the course. But what is the next step? The next step is this: practice, practice, practice. Now I'm sending this out to all of my students because I have some students who have not stepped into the IT world and they want to learn about this IT, my CIS 101 class. But I want them to see what you have to do to become really good in this field. You have to practice. You have to sit down and build labs up. I know you in other classes, but do not lose the ability to practice. I like to create a separate document to utilize to walk through the steps of this. So I have my document down here on this screen. Instead of looking at that particular document, I'm just going to come down here and put this document on the screen below so I can follow the steps. But I will be following the steps that's right here on the side. Remember, people, you have to get really good at this, and the only way you can get good is by practicing. Don't let nobody tell you anything that you have to be born to know this knowledge and all that. It's just simply practicing. The more you practice, the better off you get. So with that being said, let's move forward. Now, we know the objectives are important. At the end of all these labs that I'm going to be producing, I am going to come back and do this again. But this time, I'm just going to do it with the title and the objectives. I'm not going to go through the material because at that point, that's when you start remembering things and know how to do it. Okay, I might read over it once because we got a lot of labs to get through. I want you to start recognizing you can do this, you can remember this, and you can work in this field. The first thing is examine NAT configurations on a wireless router. Set up 4 PCs to connect to a wireless router using DHCP. You know what DHCP is about. It is the protocol that gives all the system computers their IP address. And then we examine NAT. Now remember, NAT is just simply network address translation. We want to know, how do we get the information inside the corporation outside of the corporation? All you have to do is follow the instructions to know exactly how to get information from inside the corporation outside the corporation. In other words, traversing over the internet onto a server that's out there. Like for instance, if you want to go to any website, you actually landed on a server somewhere if you're using your computer. So the first thing I'm going to do is I'm going to come down here and choose a PC, put that there, and then I'm going to go get the connection of that PC, which I'm going to use a straight through cable. You can see that at the bottom, straight through cable. And I'm going to go ahead. Oh, I grabbed the wrong cable. Let's go straight through and click on it, connect, and we're going to connect to the Giga Ether 1 on the wireless router. Now remember, if you was in a real world scenario, you'd just be plugging these cords into the wireless router, and the PC. Now, that orange light or umbral light, we're going to fast track that so it can go away. And I'm going to move this here. Now, I'm going to go ahead and from here, go to the PC. And from the PC, well, let's make sure I follow the instructions. I know what I'm doing, but I want you to see the instructions. So the next thing is to go to the desktop, then go to IP, and we just gonna take it from static to DHCP. Now, you know, static is when we put IP addresses in. With DHCP, that means the server is giving it an IP address. So I'm gonna go ahead and click it, and you'll see the IP addresses right there. Simple. Okay, from there, we close that. Now we move to the next step. And the next step is to simply go to the web browser. And from the web browser, we're going to put the IP address in. Now we know that's going to be 192.168.1.1. Okay, I put a 2, but we know it should be a 1. And then I hit enter, and then I just add the username and password. And you can see right here that the username and password is just admin. So I'm gonna go ahead and type that in, and then do the same again. Okay, now what you just did was teleported yourself connected to the wireless router. And you can see in here the many different things in a wireless router. When you get a chance, when you go back over this lesson, just look at it. Now we're gonna go straight to the status, and from status, we're gonna see IP address. Now these IP addresses that you see was given to the corporation. So how do this work? The corporation goes to a ISP and asks them for IP addresses to put on their router so they can actually connect to the outside internet via the internet. Okay, so these IP addresses are what we call public IP addresses. The IP addresses you use within your organization is called private IP addresses. The private IP addresses are for inside the organization, whereas the public IP addresses allow you to stay within the organization. And remember, ISP is just for Internet Service Provider. So that's T-Mobile. If you're in the United States, that's T-Mobile, that's Verizon, etc., etc., etc. You know all the ISPs out there. Anybody who's selling you internet is an ISP. Okay, AT&T. Okay, so let's move on. So you see this right here, and that's all I had to do was click on the static. Now it says scroll down and you see these IP addresses. Remember, these are public IP addresses, the ones that allow you to traverse the internet. Okay, now let's go to section 2. Now section 2 simply says click on local network. So if I go right here, you can barely see it, but that's the local network. Now you see these IP addresses here. These are private IP addresses, and these are the IP address, and you can see right here, this is the router IP address, 192.168.1.1, the one I just typed in. So these IP addresses are in a coupler inside the corporation. They do not traverse the internet. They do not go across the internet. They are private IP addresses. Let's move on to part 3. In part 3, we're going to close this here because we don't need it anymore. Just make sure you look in there. Go back. Do these packet tracers again so you can make sure you grasp the information. This is something we do on a daily basis in an organization, depending on what your job title is, but you should know this. Okay, now we're going to put some more computers on here. So I'm going to go ahead and grab some more computers. I'm going to say 1, I'm going to say 2, and I'm going to get a third one. So that gives me 4. I'm going to slide this over here. I'm going to put this right there. I'm going to go ahead and grab the cable in, do the same thing. Fast Ethernet, come right here. Giga Ethernet 2. Simple stuff. This is not hard. No matter what career you're thinking about going into, You should know how to do this. That's why you took my class. And for those of you who haven't taken this level of class, you see this is not hard stuff. This is really easy. And it's just practice. That's all. Practice, practice, practice. And that's what I'm doing with these labs. I'm going to continue to push these labs out so you can see all you have to do is practice. Let's go get the last one. Connect that. Okay. I clicked on the wrong thing. Do it again. There you go. Booyah. We got that. We got that. I'm going to fast track it so we can get that green out the way. And that's pretty much what you had to do. Now let's go give them IP addresses. Remember, you go into the desktop. So if I'm sitting at a computer, I click on the desktop, I come right here, I choose DHCP, I get a roll of IP addresses, I close this because I no longer need it, go to the next one, I do the exact same thing, I click on it, DHCP, IP addresses jump in. So what's happening here is that the DHCP is giving IP addresses to these PCs. Just that simple. That's all it's doing. Click it here. Now, of course, on the back end, the network administrator or the network engineer put these IP addresses in. You will not be doing this part where you configure the router to either dispense IP address or configure the server to dispense IP address via DHCP. And that's one thing I want to make clear. You can have a router, and we do it all the time, that distribute IP addresses. We make a router, a DHCP, and we can have a server distribute IP addresses. We make the server do it. So depending on how big the corporation is, that's how we get it to dispense the IP addresses. We make a decision on should the router do it, should the server do it. I'm gonna go ahead and click on the command prompt. And then I'm gonna come to here to the command prompt. You know this word here, which is IP config /all. You should know this is one of your tools to make sure that your systems are up and running. And you can see that we have IP addresses here. Okay, let's go ahead and close that. So we did that. Let's go to step 4 now. Now, step 4, we're going to go ahead and mess with NAT. We're going to view NAT transactions across the wireless router. So what we want to do here is we want to go to the simulation mode. And in simulation mode, we're going to have a packet run from here to the server, just to show that everything is configured right. Normally you'll ping it. One of the things that you learned in this class was how to use Wireshark. Wireshark allows you to see the packets traveling over the network and what problems you can have. And you need to get good at Wireshark. What I'm gonna do is get rid of all of these protocols right here. I'm gonna clean them out. And then I'm just gonna choose 2 protocols that I deem important, and they in here. One is going to be TCP, and the other one is just going to be a web protocol, HTTP, right there. So I got those 2 protocols. You see they jump down here. That's my filter. Now I'm gonna come up here and use this envelope right here that allows me to send a PDU showing how information travels around the network. That's what I'm gonna do. I'm gonna click on that envelope, and then I'm gonna just click right here. Okay. Now, once I click right there, according to this, I wanna do some particular settings. Like I wanna change this to HTTP right there. I wanna go here in this IP address. I wanna come over here and click on the actual server, and then you see it put that IP address in there. And then from there, I want to come down here into the port and put 1,000, okay, for that particular starting source port. Then I want to drop down here, and once I drop down here, I want to change this to periodically, and I want to go right here and put 120 seconds. Then I'm gonna go ahead and create this PDU. Now it's created. I'm gonna go ahead and start it. Okay, now watch what's happening. You see, it's actually finna make the transfer to here. Okay, and you see it going there. So that's what's important about this, understanding how NAT works. Now, let me give you a deeper understanding here. So these particular PCs have IP addresses. These are private IP addresses. The IP address cannot go across the internet. Well, you'll say, well, Professor, we're watching it right now go across the internet. On this port right here going into the cloud, I got an ISP address from my internet service provider, and then that is taking these IP addresses and transferring them via NAT, which is a protocol, so they can travel across the internet. So it's one IP address that's sending this information. Now, NAT is deeper than what I just said. So we're going to learn a lot more about it as you go through your networking classes. But all you need to learn from this particular lesson is that you got private IP addresses that cannot travel over the internet, and then you got a public IP address that will allow your information to traverse the internet, leaving out of your organization. Okay, that was a simple setup. Wasn't that hard at all? Okay, so we're going to keep this lab short. And I want you to remember that if you find that this information was helpful, please feel free to like and subscribe, and I'll see you in the next video log.